Hi everyone, so this is a review for revision quiz chapter 14, thermodynamics, set 1. So based on the responses here, I think we'll be discussing question 5, question 13, 15, 17, 18, 23, and 25. A total of 7 questions. So let's look at the first question then. Question 5. The pressure of an ideal gas in a vessel of fixed volume is P. Okay, so they say the pressure of an ideal gas in a vessel of fixed volume is P. So from here, your first thing you can say is that the volume is constant. Okay, and they now tell the pressure is P, but we're not sure why they give this, so we leave it here first. Let's continue and read the sentence. If the gas in the vessel is heated, okay, something important, so that the RMS speed of its molecules is increased 3 times. So RMS speed is increased 3 times than the initial value. What is the new pressure? Oh, so now we know the pressure that they mentioned here is actually the old pressure. So let's call the old as 1, the new as 2. The standard practice to use old as 1, new as 2. Okay, so here we can say pressure 1 is equals to P. Then the next thing that we know is the RMS speed is increased by 3 times the initial value. So VRMS 2 should be equals to 3 times the VRMS 1. So now they ask for the new pressure, which is P2. Okay, so now knowing that, we can start to solve the problem. So how should we approach the question? Well, there are many ways to approach the question, but it seems that many of you still cannot really get how to solve this kind of question. So let me use a standard way to do this thing. The standard way is, first thing is, find what relationship you need to express. Find what relationship to express. So what does it mean is, what are you finding here? You are finding P2. And as you can see, the answer here, they are all expressed in P, which is the old pressure. So now what you need to find is actually the relationship between the old pressure and the new pressure. That means what you are trying to find is actually P2 over P1. That is what you are trying to find. Okay, so after you know this is the thing that you need to find, the next thing you need to know is what information can you relate it to. Okay, so what does this mean is, you know you are finding pressure, the relationship between pressure, but of course you know there are other info that are given to you. So some other info that are given to you is, you are given to you VRMS, and you are given to you the volume, which is constant. So now later on, you need to express this pressure here, you need to relate it to these two kind of things here, which is VRMS and the volume. So let's try to figure it out, how to relate this thing together. So VRMS, we are very familiar with the formula that it can be 3RT over the molar mass. Okay, so nothing here seems to be similar with pressure. Remember, we are trying to relate VRMS here back with pressure. We are trying to relate it in terms of pressure, and there's no such thing as pressure here. But don't worry, see here, temperature. Temperature, you know that there's something that we call as PV equals to nRT. So you can shift it to be RT equals to PV over N. So knowing that, we can modify a bit our equation to be VRMS Then we substitute the RT with PV over N, so it will be 3 PV over N M. Okay, N is the number of mole, M is the molar mass. So this is the equation that we get. Okay, so now you can see that I've successfully able to relate volume and VRMS, volume. I am able to relate it to the things I want to find, which is pressure. So what would I need to do now is to express it in terms of pressure. So to express it in terms of pressure, I'll need to make it to be VRMS square equals to 3 PV over Nm. Then I'm going to shift everything to one side, leaving pressure at the other side. So there'll be VRMS square Nm over 3V. Okay, so now I'm able to successfully relate pressure with VRMS, and volume. So I've achieved what I want to achieve for section 2. What information to relate it to. Based on what's given, try to relate it to what you want to find. Okay, work on it strategically. Okay, I get it right or wrong. Okay, so number 3 is you can start to do your algebra. Then basically you manipulate the equation. So how do you do? P2 over P1. So after that, you just write VRMS 2 square N2 M2 divide by 3V2. You divide by VRMS1 square N1 M1 over 3V1. Okay, so this is what we have done now. So let's try to do something that we know from our question. We know V is constant, means V1 is equals to V2. Okay, then based on the situation here, they don't tell you there's any gas that gets out, and they don't tell you they change the gas. The gas is still the same gas, so that will mean if the gas is still the same gas, then that will mean the molar mass for the old situation and the new situation should be the same. And since the gas does not goes out, there's no new gas coming in, the number of mole of gas in the container should be the same. So all of this you can replace it with V, replace it with M, replace it with N. So now if you modify the things a bit, it will be VRMS 2 square, then N M over 3V. Then you times, then you have 3V over VRMS 1 square and M. So now there's a lot of things that you can cross out. The 3V and 3V can cross out, and M cross out. So essentially what you're left with is VRMS 2 over VRMS 1, and they are both square. So you know the relationship between VRMS 2 and VRMS 1 to be VRMS 2 equals to 3 VRMS 1. So you can do a bit of substitution. So that will be 3 VRMS 1 over VRMS 1. Then again, you can do a bit of potong. Then you are left with 9. So essentially, you know P2 over P1 is equal to 9. Therefore, P2 is equal to 9 P1. And you know P1 is equal to P from the question. That's why P2 is equal to 9P. So from here, we are able to get our answer. Our answer is D. Okay. So the thing that I have introduced here is actually a general way of doing ratio question. First, find a relationship to express. Then what information you need to relate it to the thing that you want to express. In this case, you want to express it in terms of P, and the information you have is VRMS and V. So find the expression which you are able to express the thing that you want to express in the terms that they are given with. then only that you try to find a relationship for all the things and try to work on the algebra. Okay, it's a systematic step. Once you get used to it, you are able to plug it in many different questions. Okay, so that's all for question 5. Let's move on. Question 13. When the average kinetic energy of the molecules of an ideal gas in a closed rigid container is increased by a factor of 4. Well, that's a lot of words in a single sentence. Okay, let's slowly talk about it. Average kinetic energy, that's what we say. Average is this triangle bracket here. Then kinetic energy is K. Of the molecules of an ideal gas in a closed rigid container. If it's closed and it's rigid, closed means by there's no particles going in and out, so your N is constant. So if they say it's rigid, then probably it means the V is constant. It means by the wall of the container cannot move. So V is constant, N is constant. And it's increased by a factor of 4. So they say the new average kinetic energy, it's increased by 4 times of the old average kinetic energy. Okay, so what happens to the pressure of the gas? They're asking for pressure. So again, it's something that you need to relate between. Okay, let's do it step by step, again using the same step. First thing, what to express? As you see, they are relating something. They are talking about pressure here. And they say it increased by a factor of 4. So comparing with what that they say factor of 4, it's comparing it with the old pressure. So the new pressure is 4 times the old pressure, or 2 times the old pressure, or 8 times the old pressure, or not change. Okay, so that's what they want to express. They want to express the pressure. So you know that you need to express P2 over P1 once again. Okay, so the second thing is relate to what? What do you need to relate it to? You know, they give you something. They say the N is constant. That means why you have to relate to N, probably V is constant. It's not necessary you need to relate to everything. Okay, but these are like hints for you what you need to relate it with. Then K. Okay, K is your average kinetic energy. So what can we do here? Well, this thing we know the formula. This thing we know the formula for sure. There will be the average kinetic energy equals to F over 2 kVt. Okay, I don't think it's necessary to differentiate whether it's the average, the total average kinetic energy means right for all the molecules or just for one single molecule. Okay, when the average kinetic energy of the molecules of the ideal gas. Okay, they didn't really specify very clearly. Okay, so I assume it's asking for one molecule, let's say, but it's not important. Okay, there's nothing important about it. So now you see you have K, but you are still far away from pressure. But you still know that there's something called PV equals to nRT. So the something that you can sub out here is T. Okay, so T will be equals to PV over nR. Oh no, because you are in kBt, so let's do it in kBt. Sorry, my fault. So it should be PV equals to nkBt. I'm using the per molecule formula, not the molar formula. So if you want to be in T, then it will be PV over nkB. So F over 2 kV, then you have PV over nkB. So now something definitely can be crossed out. This can be crossed out, this can be crossed out. Then you are left with F over 2 PV over N. Okay, so if your molar mass, not molar mass, number of mole is constant, that will mean by your number of molecule is constant. Okay, number of mole constant, number of molecule will also be constant. So what can you know now? F here, it's a constant. Okay, if it's diatomic, then it's 5. If it's monoatomic, it's 3. If it's polyatomic, then 6. Then if you go, only if it goes to very, very high temperature, add 2 or you add more. But usually we just ignore the very, very high temperature. So you can think of the degree of freedom to be constant. Then now they are asking for pressure, so pressure definitely will be changing. But the V is constant because it's a rigid container, and N is constant because it's a rigid container. So essentially, what are you finding? N is rigid. N is constant because there's no molecules going in and out, not because it's a rigid container, sorry. So essentially what you're comparing here, you're comparing the relationship between average kinetic energy and pressure. But again, we want to express things in pressure, so let's rearrange the equation. So it can be 2N average kinetic energy divided by degree of freedom times the volume of the container. So this is the equation that we get. Again, as you can see, things we want to express, the other things that we know the relationship. Okay, is either constant or increased by something. Yeah, those things we know. Then this thing is the thing that we want to express. Okay, so knowing that, we can start to do our algebra. Algebra, again, P2 over P1. Then we write down everything that we know. 2N1 average kinetic energy 1 divided by FV1. Okay, F1 V1, let's just be a bit clearer, do things a bit slow, that's fine. Average kinetic energy 2 over F2 V2. Okay, so we know from just now V is constant, so V1 is equals to V2 equals to V. Then we know N is constant, number of molecules is constant because no molecules go in, no molecules go out, equals to N. Then we know the degree of freedom, as long as it doesn't change temperature by too much, it doesn't enter a very, very high temperature or very, very, very low temperature. If you don't enter this two range of temperature, your degree of freedom should be constant. And the next thing that you know is the average kinetic energy. Oh, I think I did make some mistakes. Okay, the average kinetic energy 2, it's how much? Increased by a factor of 4. It's 4 times the old average kinetic energy. So what mistakes have I made here? Okay, the mistake that I've made is I flipped the 1 and 2. Okay, definitely my bad. Okay, let me rewrite it again. So it'll be N2 average kinetic energy 2 F2 V2 N2 N1 K1 F1 V1. Okay, so this is what we have here. So let's start to do a bit of stuff. So let's express it in the terms that we agree on over here. We agree to express it this way, so let's express it right now. 2N K. 2 is equals to 4K1. Messy. 4K1. Okay, then you divide it with the degree of freedom is F, then the volume is V. Then you have your 2 and so I express it as K1. Then this one you have F and V. So once you reach this stage, you can see that this can be cancelled out, the 2N can be cancelled out. So what you are left here is 4 average kinetic energy 1 divided by kinetic energy 1. So again, you can cross this out, then you're left with 4. So the new pressure divided by the old pressure is equals to 4. So you can say the new pressure increased by a factor of 4. Increased by a factor of 4. So our answer will be B. It increases by a factor of 4. Again, you see if I follow through this step, you will get the thing that you want. You just need to be, the step 2 is a bit complicated, but with practice, you should be good at it. find what equation can be relevant, then manipulate the equation to be in a form that you can express P with something that you know from the question. Okay, so that's all for question 13. Let's move on to the next question. Question 15. A mixture of two gases at constant temperature contains two types of molecules. Okay, this sounds like a chemistry question rather than a physics question, but never mind, it's still a question. Okay, so you have a gas container. Then this gas container, you assume inside there's a mixture of molecules. So there's this yellow type of molecule, and at the same time, in the same container, there's this green type of molecule. So two different kind of molecules, then they mix together to become a gas mixture. And this gas mixture has a constant temperature. T is constant. Okay, then they say one of the molecule has a mass of m per molecule, and the RMS speed is c. Then you have another type of molecule, let's say this green molecule here, that the mass is m prime, and the VRMS it's c prime. Okay, so now they ask for the ratio of c against c prime. Okay, so this question is slightly more straightforward. You already know what to express. What to express here is c over c prime. So remember, c is root mean square 1. C prime is root mean square 2. So essentially, you want to relate root mean square to the other stuff that you know. Okay, so what other stuff that you know relate to what? Okay, so what do you know? What do you want to relate it to? You know that there's mass 1, which is equals to m, and there's mass 2, which is equals to m prime. And you know there's VRMS 1, which is equals to c, and there's VRMS 2, which is equals to c prime. So you know VRMS and the mass per molecule, it's something, probably a formula that you can recall. It's VRMS equals to, well, here you might be thinking whether I want to do 3RT over molar mass, or I want to do 3kBT over small m. Okay, molar, if you're doing things in per mole in your case, you should use mole, then this you should use R. If you're using molecule case, if you're focusing on one molecule, then you should use Boltzmann constant. Okay, again, I remind, it's a habit of me to write KB, but in your syllabus is K. Okay, I write KB because I prefer not to confuse it with like thermal conductivity, spring constant, those kind of stuff. Okay, but in exam, write it as K. That would be better. Okay, we respect our syllabus. So that will be 3kT over small m. Okay, the big M is molar mass, and the small m, it's the mass per molecule. So as you can see, they give you the mass per molecule, they don't give you the molar mass. Means by they are focusing on the molecule case. They are not focusing the gas as a per mole situation. They are focusing on the gas molecule. So in that case, this equation here will be more appropriate. So VRMS is C, and the things that you know, it's here. So I think this is the appropriate equation. There's no need to manipulate it anymore. So now they want C over C prime. C, it's VRMS 1. So you can start to do algebra straight away. So here they are finding VRMS 1 over VRMS 2. Okay, then they are both equals to 3kt. Okay, I write t1 first over m1, and this one will be over 3kt2 over m2. Okay, so what do we know? We know that T1 is equal to T2 because they are in the same mixture. So the same mixture have the one temperature only. So T1 should be equal to T2, and therefore they should be equal to T. So here we can do a bit more manipulation already. So 3kt over m1, they call it as m, multiply by, now you know 3kt is down there, but the mass 2 is equal to m prime. So you know there's plenty of things to cancel out. Cancel out. Then you are left with square root of m prime over m. And this is equals to c over c prime. So from here we are able to know that our answer should be, D. Okay, again, you can see I've done 3 questions, then they are all following the same steps. What to express, relate to what, and you do the algebra. Okay, I'm trying to show you that this systematic way of doing things can be applied all across all comparison questions, usually. Okay, so next question. Question 17. Question 17 says, the graph shows a relationship between Pt and 1 over V of a sample of ideal gas. The gradient of the graph represents. So I forgot to attach the picture of the graph which is larger. I'll just draw it here. So this is a P over T against 1 over V graph, and it's a straight line. So if it's a straight line and you want to find the gradient, what will you do? You'll be taking this P over T2 minus this P over T1 divided by the 1 over V2 minus 1 over V1. Okay, so this is the gradient that you normally do. But you see, the key point when you're doing gradient, which is equals, gradient is m, the symbol for gradient is m. So you can see it's usually delta y over delta x. So the key here is it's being divided. Okay, if you do gradient, it comes from divide. Okay, but if you are finding area under the graph, then it's multiple. Okay, area under the graph. If it's area under the graph, then the thing should be a multiply. Should be a multiple. Okay, because when you're finding an area, right? You take the length times the width, right? You don't divide, right? Okay, that's why area comes from multiple. Okay, so now we know that if you're finding gradient, it should be a divide. So a rough idea of how to do this thing is you can straight away take the y-axis, which is P over T, divide by the x-axis. This is just to let you know what you are getting when you do the gradient. So now you know that if I flip a bit, then it becomes PV over T. Now try to find PV over T in the answer here, and I believe you can't find any. You can't see the word pressure, you can't see the word volume, you can't see the word temperature. So what should you do is you should try to express this thing in other things. Well, if you see PVT, something should pop out in your head. So PV should be equals to nRT. So PV over T should automatically be equals to nR. So what this means is it's actually equals to nR as well. And nR, it's number of moles times gas constant. R is called gas constant. So do you find this thing in the answer there? Well, I believe the answer is again no. You can see there's no number of moles, there's no gas constant. Oh, there's gas constant, okay, but there's no number of mole involved. But you see here they give everything like number of molecules. Number of molecules means that what? They are actually doing things in the molecular basis, not the molar basis. Okay, so you are able to choose another equation. Okay, so in this case it will be PV over T equals to capital N KB. I just want to remind one more time, these two equations, PV equals to nRT and PV equals to NKBT, they are the same formula, just from different perspective. If you analyze this gas in a molar basis, then use PV equals to nRT. If you analyze this gas from a molecular basis, then you use PV equals to NKBT. They are the same formula, they have the same usage. Just like if you are doing things on the molecular basis, you use the NKB version. If you are doing things in the molar basis, you use the NR version. Basically, you see what they give to you, then you pick the appropriate formula. You can think of it like that. Okay, so now you know that this can be NR, but it also can be NKB. So I'll just write it outside here. So the M can also be equals to NKB. And N here is number of molecules. And KB here is Boltzmann constant. Okay. So this is Boltzmann constant. So knowing that, we know the answer will be A. Okay, so that's all for question 17. Let's move on to the next question. Question 18. The RMS speed of the molecules of an ideal gas at pressure P and volume V is C. That's a long sentence again. So they say the RMS speed is C. Okay, RMS speed is C. So let's write it down first. VRMS 1 is equals to C. And then they tell you also that this pressure is equals to P and the volume is equals to V. Okay, and that's what we know from the first sentence. You know the pressure is P, the volume is V. Then now the gas is heated. Then when the gas heated, then the volume becomes 2V. Volume becomes 2V because of this heating process, and the pressure becomes 5P. So now you know that the volume becomes 2V and the pressure becomes 5P. Then what is the new VRMS speed of the gas molecules? They are asking for the new RMS speed. So, well, again, what they are doing, same thing again, the 3 steps process. What to express? Well, you know you want to find the new RMS speed. So it means that you also want to express it in terms of the old RMS speed, because the old RMS speed is equals to C. So you're expressing it in terms of C means by you are finding a relationship between the old RMS speed and the new RMS speed. So it should be VRMS 2 over VRMS 1. So that's the thing that you want to express. The second thing you want to express is relate to what? Okay, so what do you want to relate it to? Well, they give you P, they give you V. So then you know you want to relate to VRMS. Well, the first thing that we know is VRMS is equals to let's do 3RT version then. Okay, 3RT over M. But well, they don't give you anything about T, they don't give you anything about M. They want you to relate it to P and V. So you know P and V and T are actually related by PV equals to nRT. So if you express it in terms of RT, then it will become PV over n. Why does this question sound so similar? Okay, so from here you are able to know that your next step will be 3 PV over nm. And this equation, essentially, it relates the thing you want to express to the thing that you are given information with. Okay, so that's the equation, and we are going to do a bit of algebra with this equation. So let's move on to the algebra. Again, we are expressing VRMS2 over VRMS1. And let's write down the formula. So it will be 3P2V2 over N2M2 divided by 3P2P1V1 over N1M1. Okay, so we have information about P, we have information about V, but how about N and M? The number of moles should be the same because they don't say any gas come out or goes into the container, and the molar mass should be the same because they didn't tell you I changed the gas. They just say the gas is heated. They don't say I changed the oxygen gas to be nitrogen gas. No such thing. Okay, so in that case we can say that N1 will be equals to N2, then therefore it will be equals to N. M1, the molar mass of situation 1 should be equal to the molar mass at situation 2, and they should both be the same molar mass, capital M. So knowing that, we can rearrange a bit our equation to be 3P2 is 5P, V2 is 2V, over the N should be the same, the M should be the same. Multiply by, the NM is now up there. What's down there is just 3PV. Okay, so now once we have reached this stage, again it's potong time. So 3 can be removed, PV can be removed. So what you are left with is just square root of 10. So square root of 10, then you know VRMS2, they express it as to know, so that's VRMS2. VRMS1 is C. So essentially, VRMS2 is equals to square root of 10 C. So that's our answer. Our answer is A. Okay, I think most of the questions in this chapter are doing the same thing. It's all ratio question. So if you get one, you practice more, then I believe you can get everything. Okay, don't worry too much. It comes by practice. Okay, so next question. An RMS speed of air molecules of 485 meter per second at standard temperature and pressure. It should not be N, probably the RMS speed. I'm not sure, I might copy it wrongly. Okay, so the RMS speed is equals to 485 meter per second at STP. So if they say it's at STP, then no standard temperature and pressure. So the temperature should be 0 degrees Celsius or 273.15 Kelvin. Okay, write it down. The pressure should be 1 atm, which is 101325 Pascal. Okay, that's the information being given in the first sentence. So the question asks, this mean that at standard temperature and pressure, okay, they ask and they ask you to fill in the continuous sentence. So it means that we have to read what are the question asking, what are the options given. They say most of the air molecules move at the speed of 485, or all the air molecules move at the speed of 485, or the mean speed of air molecules is less than 485, or the mean speed of air molecules is 485. So there's slight difference between all sentences. This one is most of the air molecules. This one is all the air molecules. This one is mean speed is 485. This one is mean speed less than 485. So what essentially you need to do is you need to understand what's the meaning of RMS speed to be able to answer this question we need to know what's the meaning of RMS speed. Well, this question is slightly conceptual, so you have to recall what is RMS. RMS is root mean square. Okay, so the subject that being undergo RMS is V. So it means by you have V square. Because of square, you square. Because of mean, you do mean. Because of root, you square root it. So that's the idea of root mean square. Okay, it's the square root of the mean of the square. Okay, probably there's better way of sentencing this thing, but again, it's you square something, then you get an average of it. Average is also called mean. You square it, you get the mean, then you square root it back. Okay, essentially that's the meaning of root mean square. So root mean square, does it mean is the speed that most of the air molecules have? No. Okay, this one is slightly out of syllabus, but there's another term that represents this. It's called the most probable speed. Probable speed. Okay, it's a speed which has the highest probability to be at. Okay, so actually in our gas, there's many gas molecules, right? And all of them are actually moving at different speed. So the different speed actually forms a spectrum. Some of them are slow, some of them are fast, some of them are around the middle. So the most probable speed will be the speed that most of the particle has. Most of the particle will be moving at that speed. That we will call most probable speed. But that's not VRMS speed. Okay, VRMS speed is another thing. VRMS speed is an idea of an average, but a different kind of average, because if you do a proper average, you'll be cancelled out. Okay, so this is wrong because that should be most probable speed. Next, all the air molecules move at a speed of 485 meter per second. No, as I say just now, all of them move at different speed and they form a spectrum. Some of them moving fast, some of them moving slow. Okay, the third thing is the mean speed of air molecules is less than 485. Well, you might not know much about this, but the next thing is the mean speed of air molecules is 485. For this, if you look back to my lecture video, I say if you calculate the mean straight away, right, you should probably get 0 as your answer. Okay, but it's actually not 0. Okay, 0 is like a idealized situation, but in actual it will be a value, but this value will be smaller. Mean speed is always smaller than RMS speed. Okay, this is due to some mathematics stuff, but you know that mean speed is less than RMS speed. Why mean speed is always less than RMS speed? I will discuss it in the next question. Next question discuss this thing. So if they say mean speed is 485, then root mean square speed is 485, then that means root mean square is equals to mean already, and that's wrong. You know the answer is it's smaller, so the answer is wrong. Okay, this sentence, what this sentence basically means is, just in case you're not sure what am I saying, it says mean square of the air molecules is 485. Then from the question they say RMS speed is 485. So if you combine these two sentences together, what it mean is the mean speed will be equal to the RMS speed if you combine these two sentences. And we know from my explanation just now, it should not be equal. So the answer definitely will not be D, and the answer will be C. The mean speed of air molecules is less than 485. Okay, if you still feel like I haven't explained to you, yes, I haven't explained to you why mean speed is less than 485. Why mean speed is less than RMS speed? We need to look at the next question. So let's look at the next question. Question 25. The speed of 5 molecules are K, L, A, M, and P. K, L, M, N, P. These are the speeds of 5 molecules. Then they say, which of the following are the RMS speed and the mean speed of the molecules? Okay, so they are asking which formula, which expression here represents RMS speed and which one represents mean speed. Let's start with mean speed first. You know, if you get something like a mean, you get mean of x, let's say, you can also call it as x bar, which is like the centroid you calculate. Basically, you get x1 plus x2 plus x3 plus x4 plus blah 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 until plus xn. Then you divide by n. Basically, you are getting an average here, right? So which one here looks like the mean speed? Well, you definitely know that mean doesn't involve anything squared. This will be wrong. Then doesn't involve any square root. This should be wrong as well. So these two should be fine. This looks like average to me. Okay, then the next thing is you focus on RMS speed. Okay, so remember it's the square, v square already. Next thing is mean. Mean is we find the average. Next thing is we find the square root. Okay, so we do the same thing. We want to find the mean of v square. Means by our v, there's k, l, m, n, p. So if you want to find v square, there will be k square, l square, m square, n square, p square. So these are v square. So this v square, want to find the average of it. So you know how many terms are there? There are 1, 2, 3, 4, 5. Your n is equals to 5. So therefore it will be k square plus l square plus m square plus n square plus p square. And you divide it by 5. So this thing that I write here represents the inside here. Oops. Represent this thing here. But now I add on a square root on the outside. If I add on a square root on the outside, that means by I add on a square root on the outside. So which of these expression match this? You know, this one should be wrong because the 5 should be square root as well. Because you get an average first, only you root it. So it means that you get your average first, only you root it. So the average divided by 5 should be inside the square root. So with that, we pick our answer to be C. Okay, so now I want to explain the thing that I left out from the last question. Why VRMS will be greater than mean speed? It's because actually this thing is a bit too complicated for me to explain. I refer you to a video which I find very useful in explaining this thing, but it's somehow related to Pythagoras. Okay, Pythagoras, you know that for Pythagoras the hypotenuse should always be the longest side. Okay, then you see that this thing is being constructed by taking a, if this is a, this is b, then it will be a square plus b square. Then you see that a square plus b square has a similar shape to our root mean square. It has something square, then you sum up the square, then you square root it. The exact explanation is much more it's a bit more complex than this. My explanation in fact is a bit wrong, but you see that the longest has a shape of a square sum and then square root. Okay, but honestly I don't think I can explain this thing well. What I will do is I'll refer you to a video and a specific time frame. Look for it at the description. I believe that video will be very helpful for you to understand why root mean square speed should be greater than the mean speed. Okay, with that said, I believe this is the end for our review for chapter 14, quiz set 1. Thank you very much.